Hey there, believe it or not, insects are crucial to our way of life, but their population is dwindling while the human population is growing. This is bad news. Stay with us for this show to find out why we should respect insects. We've got two great guests in this special Friday night show. Later on, we'll be joined by Professor Julian Vincent, who has published over 300 papers on ideas like materials and biomimetics, what we can learn from living things. And we will also be joined by Bridget Nicholls, who's the founder of a really fabulous event called Pestival, which she'll tell us all about. But this is the Disruptive Innovation Festival, and my name is Colin Webster. I'm part of the education team at the Ellen MacArthur Foundation, and I'm delighted to be hosting this event on the second week, the last day of the second week of a 3-week-long festival, the Disruptive Innovation Festival, which explores the question, the economy is changing, what do I need to know, experience, and do? And tonight, we're going to talk about insects. And with me is, as I said, Bridget Nicholls. Bridget, I had a look at your biography, and you have described yourself as a cultural entomologist. I don't think I've ever met one before. What does a cultural entomologist do?
Well, it's someone that really wants to promote the importance of insects in everyday life, from technology to future-proofing our very existence to medical applications, and really get everyone around the world excited about it.
All right, yeah. Okay. So give me, I know you do something that does get people excited about insects, and I gave
What's that?
Well, I gave a teaser of it just a second ago.
Right.
It's this thing, Pestival, right?
Yes.
It's a big event, I understand. Yeah. Can you tell us, well, no, we're going to come on to Pestival soon, but first, my question was going to be, why should we respect insects? That's the title of this session. Why should we respect them?
Well, insects have had a very bad press. But the reason I got into insects is because of how many there are. So obviously be on the side of the most, and there's 10 quintillion insects in the world and about 7.5 billion humans, so I'm on their side. That aside, but seriously, obviously 80% of plants in the planet need insects to pollinate them, and up to 80% of human diet needs insects in some way. And since 1980, 45% of insects have died out, whilst the human population has doubled. Well, nearly doubled. So we're at the tipping point. We need to start really thinking about what that means in terms of the planet, because insects, without them, we wouldn't be here. We wouldn't have the planet as we know it. So we've really got to sit up and go, we need to respect these things.
And that's a huge figure. What did you say? 45% of insects have died out since 1980.
Yeah.
What's killing the insects then?
Well, apart from us, lots of factors. Changes in climate change and weather, in deforestation, urbanization, pesticides, DEET, all sorts of things that, you know, we're creating a different balance in the world. And the insects, especially certain insects like butterflies, are the canaries. And we really start having to see what's going on with them.
And I guess when we use things like pesticides, we kill off these bugs that are eating our crops, and we think we're doing the right thing. There are unintended consequences of that action, I guess, right?
Unintended consequences, of course, we eat them too. So either way, we get it, as well as the insects. So it's that whole, looking at the whole planet and having a human, animal, and ecosystem health imbalance. And what does that really mean? And what that really means is looking at the bottom of the pyramid, is the insects holding it up? And without them, we could be stuffed quite quickly. And if they're disappearing at that rate, we need to do something now.
Right, and we should respect them because they've been here for longer than us, right? This is more their planet than ours.
Well, it's everyone's planet, let's not go far. But they've been here for what, 350 million years or so. We've been here in this form for around 200,000. So they clearly know a lot of things, and we need to know them. And they've designed themselves to perfection in a very sustainable way, to live in the environment in a very low cost, low waste way. And they know so much, and we're only just scratching the surface in terms of what we can learn from them. in every aspect of our lives.
They know so much. What do you mean by that?
Well, in terms of what we can learn from them, in terms of living better, in terms of better well-being, in terms of better materials, in terms of better build, in terms of looking at our medical lives and how we can learn from them, in terms of creativity, just every walking aspect of our life we can learn from them. And you know, they do eat you when you die anyway, so you might as well be on their side.
Well, if it's happening regardless, maybe you don't need to be on their side.
That's true. But you know, it's the Pestival is which we're going to talk about in a minute. The reason that I came up with it is they really need our help. They've had hundreds of millions of years of bad PR. You know, they're not the most lovable things. And if you take the panda, for example, as a symbol of conservation, we love pandas. They're cute, they're cuddly, but they're not that important to the planet compared to insects. Yeah. Woodlice are crustacea, but they're allowed in.
Oh, okay. I don't know these things.
So it's really going, hang on a minute. There's 10 quintillion of them with wonderful stories, and we can really start to look at that as a way of reconnecting with the world around us. And in terms of education, then children love insects. It's their direct connection to the natural world. And so insects sans frontières, they're everywhere. Everyone knows them, they're classless. And so it's a real way in to get insects and kids to connect, because then they bring their parents. And then you start to really look at how you can educate people through bugs to get to them reconnecting with the natural world. Let's
get on to that connection then. And you're talking about kids bring their parents, and they're bringing them to something specific that you helped run this, or you founded.
Yeah.
Pestival.
Yeah, I should put the logo up. Look. Oh, there it is.
As if
I didn't even
magic.
have to do it.
Yeah.
So I started Pestival in 2006. I grew up in an animal sanctuary, and then I wrote comedy for 10 years, and somehow Pestival was born out of that wonderful hubris and combination.
Wait, hang on. What's your favourite joke about insects?
You never joke about insects. Take them very seriously. Humans you can joke about, not insects. Not insects. Okay, if you saw Stuart Lee's comedy show, he had a whole thing about doing Pestival with insects.
Yeah, I think I read his book. And
yeah, it's very hard to joke about insects.
Right, I stopped you when you were in your prime.
That's okay. So we did the first one in 2006 just to see if people would come to an insect festival, and 10,000 people did. So obviously there was a need. And then someone from South Bank Centre was there and said, would you like to put it on across our 23-acre site? So I'd never done it before, but why not? And 200,000 people came over one weekend for the love of bugs. And it was everything from mantis Tai Chi, which is the oldest practice of Tai Chi, to Blur playing insect tunes, and everyone came dressed as insects to Stuart Lee. But the real premise was creating very serious content, learnt from science research, that we could then create a wonderful story around and get great press from, and people would help science further by being part of it. So I'm going to give you an example.
Yeah, please.
So one of our main pieces was a large collaboration with Rupert Soares and the Terms Project and Software Architects. And what we did, this is actually inside a Namibian termite mound, and we dusted it down, we poured gypsum in it, no termites were harmed, I have to say that. And as you can see from this, it's like being inside the human lungs, and it's got a chimney section, and the hot air blows down the chimney, and then the termites collectively shiver to keep it at the right temperature. So engineers are really trying to understand how they create that circular air control, because then we can create free air conditioning that's totally sustainable.
Give us a sense of scale, would you? How tall is this?
Nearly as tall as me. It's about 4 or 5 meters tall. And the chimney points to the sun to get that nice angle of heat coming in. It's very clever. And what we did is we took an MRI scan of inside the mound, which is this, and then we took a 6 centimetre cube section of the chimney section, and then we blew it up to human scale as a walkthrough experience, which is 6 meters squared, and this is it on the South Bank. So you can see down here, Royal Pestival Hall, obviously a little bit of rebranding there, and we 3D, and so we CND routed it out of sustainable Austrian pine, and then we built it like a giant Jenga piece, which was in itself a brilliant showcase for the wonders of termite engineering. And then this is inside looking up. And Chris Watson, who did David Attenborough's sound piece, created this surround sound of hearing the wind blowing through the chimney and the termites collectively shivering. And then we created a light structure so that it looked like it was breathing. And this did amazingly well because it helped tell a really serious, but quite dull to most people, bit of engineering. It helped the engineer figure out a tiny piece of research he had never got funding for. And it got, insects went big. You know, we're in all the broadsheets. The BBC News at 10 was broadcast live from inside the termite mound.
Wow.
And it just was a really great way of communicating a very important story that no one would usually be interested in.
And anyone watching this online familiar with biomimicry will know that there was a building, or maybe more than one building, that was inspired, the air conditioning was inspired by termite mounds. What's the story behind that one, do you know?
Well, it didn't really work. It kind of worked. And I know a lot of engineers are very inspired by termites because termites are the best engineers. They are the best farmers. You know, they got there first. They've been honing it for hundreds of millions of years. And they live in this ecosystem under the ground, which is totally holistically run. They're actually blind termites, blind cockroaches, not ants, just so you know. And they're the only social insects that have a king and a queen. So they have this whole system of farming and engineering that's just run perfectly. And everyone knows what they're doing and they just get on with it. They've all got a role. And it's incredibly inspiring. And we've got a long way to go before we can even touch the surface of how they do it.
But it's encouraging we're trying, because if these guys can manage it with zero energy inputs and using materials which can be composted, for want of a better word, then it makes sense we would take some inspiration from them, right?
It's a brilliant sign of hope that if we can go back to basics, go back to nature, we can learn how to build a more sustainable future.
Before we move on to your next slide, just a quick word to the online audience that this is an interactive session, so please do put your questions and comments into the comments section on the page you're watching this on at thinkdiff.co, or tweet us at #thinkdiff, and we'll make sure that your comments and questions come to Bridget and they come to Julian when the time is right. So get those questions and thoughts in. Bridget, you have other things to show us from Pestival.
I do. So this was another piece that we collaborated with the London School of Hygiene and Tropical Medicine and the RCA medical designer Susanna Suarez. And James Logan, the scientist, came to us and said, you know, he's trying to capture the pheromones of people that are not attractive to mosquitoes, but it was proving difficult and his science wasn't doing so well. And we said, well, we're running a big festival. Let's help you. But obviously, we like to make it look beautiful and cool and not very sciencey in terms of how it looks. So what we did, we created this glass chamber, circular glass chamber, and then we filled it with a swarm of mosquitoes. And then we created this game, Am I Attractive? And suddenly people wanted to be attractive mosquitoes because they wanted to win. So you can see here, they're putting their hand up to the net, and the more mosquitoes that fly towards your hand, the more chance you have of winning. So if you win, you're very attracted to mosquitoes, well done. If you lose, you're very useful to science because you might help them understand how to stop the spread of malaria because you don't smell good to mosquitoes, which is obviously quite useful to all of us if we can figure that out.
So you don't literally get bitten by these mosquitoes?
No, but the scientists we work with, they actually do feed themselves to the mosquitoes. Yeah, they'll go into feeding chambers and roll their trousers up and let the mosquitoes feast on their legs.
The things we do in the name of science.
I know.
And do you, I mean, I know you're a cultural entomologist, so I'm going to ask you a question maybe you don't know the answer to, but what's the research telling us then about those of us who are resistant or unattractive to mosquitoes? Do we know, has there been any developments in terms of how we come up with a cure?
There's lots of, it's a very exciting area of science because there's lots of different scientists with different theories. And what's beautiful about it is that they all are trying to help humanity to survive. But one of the stories that I've been told about by the scientists is that they're making the male mosquitoes not able to be fertile towards the females. The females are obviously the biters because that's usually the way in the insect world. But if they can do that, that's great, and they'll stop the mosquitoes mating, and then something might happen. We might have a super group of mosquitoes, or mosquitoes might die out. But then, of course, that could be a problem too, because we're playing God. So it's a very delicate balance. If mosquitoes die out, they're pollinators, which is a great thing. But they also, which is something I'll throw out there, I don't know if I believe it or not, but they also obviously cull us as one of the main pests on the planet. So there is a kind of payoff there that if you try and stop something happening, then cause and effect means something else will happen.
Yeah, it's quite a dynamic and delicate structure, I guess.
A power struggle, I think, maybe.
Yeah, good way of putting it. Okay, so what have we got next here?
Yeah.
This one frightens me, frightens the life out of me, because this guy is about to drink these bees, is that right?
You've been watching too many sci-fi films. Yes, that's right. No, we created this, again, it was the medical designer Susanna Suarez, and it's called Pavlovs Bees. And it's around the area of, obviously we all know the bees are dying out for various reasons, monoculture and pesticides being two of those. So we really wanted to celebrate the bees and how brilliant the bees are. So what we did is created this beautiful chamber. Actually, the backstory to this was that the scientists we were working with were training bees to sniff out explosives and narcotics at airports.
Bees can do this?
Yes,
Wow.
and they were like, exactly. We were like, that is so cool. How can we take that story and run with it? And Susanna created these breathing chambers. And what she did, she trained the bees with sugar water to detect different health problems on the human breath. So this delightful character had diabetes, and what they do with a sugar water reward is swarm to the end of the chamber if you are positive for that particular disease.
So you breathe into this chamber, and the bees swarm toward it if they detect.
In your chemical makeup of your breath, they detect.
You said health problems, but it's not only health problems.
No, if you're pregnant, they can detect pregnancy too, because obviously there's a chemical balance. So it's a good news, hopefully, rather than a surprise if that happens.
So as far as we know, this guy could be pregnant.
He could be. I mean, maybe that's the future of civilization, that more human males will be having babies rather than females.
Wonderful. Okay. And do you have more slides from this year's Pestival to tell us about there?
I do have slides. Shall I tell you about this year's Pestival?
Yeah, please.
Okay. That's quite pantomime, wasn't it? Shall I tell you? So this was last Pestival, and we've had a roller coaster until now in terms of we were the artists in residence at London Zoo. Then we worked with Noma, the at the time best restaurant in the world, to create the first insect eating menu up in London. And then Wellcome Trust, who have funded us from the start, said, would you like to take the show on the road? And we said, foolishly, yes, why not? We got the backing of Harvey Goldsmith. So insects have gone showbiz and rock and roll. And what we're doing this time round is we're creating these 6 immersive worlds that tell the story of your life with insects. One for each leg, I like to think. And it's going to be the best destination in London. And each world is a world that you'd never be able to go to unless you were invited to Pestival or unless you're incredibly lucky. But having all 6 worlds together it's an immersive walk-through experience.
Right, and I know you've got some great pictures to show. We're going to come to those in just a few minutes.
Cliffhanger.
But before we do that, we've got a new feature at the Disruptive Innovation Festival launching right now.
Okay.
It's called True or False. Cue the true or false music, guys. We don't have true or false music?
Do you have to
Darn.
hug?
Okay then, let's give this a shot.
Oh.
Right, so I know you're not an entomologist, but a cultural entomologist.
Okay.
But nevertheless, I'm going to put you...
Can I make up the answer sometimes then?
Okay,
Okay,
on the spot. True or false? Insects represent 90% of all living things on Earth.
Oh, usually false, but depends who you talk to.
Well, I got my information from a children's guide to insects.
Yes, it's more around 80-something.
Well, it says true, so...
Oh.
Yeah.
80-something rather than 90.
I'll give you half a point for that. True or false? 1 out of every 4 insects is a beetle.
That's true.
That is true, yeah.
Give me entomology questions. This is mean. Okay.
Only insects eat more plants. No, sorry, only humans eat more plants than insects.
True.
False, apparently.
Really?
Yeah, insects eat more plants than we do.
Okay.
And they also eat each other, I believe.
Yes, they do. So do we in some places.
Well, yeah, okay, fair enough. Most insects do not live in a colony. They live independently.
Depends if you're talking about separate species or insects as a whole.
It's from a children's guide to insects. Come on,
These
Bridget.
are very basic questions and the answers are quite complicated. Yes. False?
False.
Yes.
Says true.
I can't remember what the question was.
Final one. No one, literally no one.
Okay.
Literally no one likes wasps. Is that true or false?
Are we talking about humans?
Yeah, people.
True.
It's definitely true.
Yeah.
I asked her in the office.
Yeah.
Definitely
Okay.
true.
Oh, was that
Yeah.
an office rather than a kids' book question?
That was an office question.
Okay,
Yeah.
right. No one here.
I'll let you recover from the true or false thing.
Thank you.
And in just a second, we are going to hear about a whole bunch of events that are coming up at the Disruptive Innovation Festival. In the last week of the festival, I'm going to pass over to Leo Nutter.
Thank you very much, Colin. I won't keep you too long because I want to get back to the conversation. It's brilliant stuff. But I thought it would be really worth highlighting a couple of sessions that are coming up in the diff in the next couple of weeks. We've had some great stuff in the last 2 weeks. And of course, I've just said that there are a couple of weeks left. There's only 1 week left. And there are some really great stuff. First of all, on Monday at 11 a.m, the founder and CEO of the Borrow Club will be on the open mic stage, I didn't put it on the screen, discussing why sharing is more important than ever. Then at 1 p.m, the Ellen MacArthur Foundation's very own Jules Hayward will be discussing the future of school with Dr. Lisa Ireland. And moving on to Tuesday at 5 p.m, on the EMF stage, we'll be in keeping more with the biotic side of things here at the Diff. Tim May and Bren Smith will be joining us to talk about the vast economic opportunities of regenerative agriculture, both in terrestrial and in marine ecosystems. And as ever, if you've missed any live or pre-recorded sessions from the last 2 weeks, you can catch up online at thinkdiff.co. One that I particularly enjoyed from a couple of days ago was a session with Beth Ratner and Ellie Benwell of the Biomimicry Institute, along with Michael Paulin, author of Biomimicry in Agriculture. And they discussed how we can design human systems and solutions using the blueprints developed by living systems, something that we've touched upon today and may go further into. And finally, just around half an hour ago, at the same time that this session started, the 4th of 5 Future Think podcasts from the School for the Future of Innovation in Society at Arizona State University has just been made available. You can check that out and catch up straight after this, along with the first 3 before that. Well, that's it from me. Back to you, Colin.
Thanks very much, Leo. And just to say, all of the events that have passed so far on the Disruptive Innovation Festival are available on catch up until the end of the Diff next Friday. Unless you get yourself a MyDiff account, look for the login feature at the top of the thinkdiff.co page. And if you get yourself one of those, amongst the benefits are you can watch sessions and catch up for the next 40 days, so through the entire Christmas period. Okay, we had a bit of silly fun there with the true and false thing. We're going to bring in Professor Julian Vincent in just a few minutes' time, because I know he's been working with you on the next development of Pestival. You gave us a teaser around these 6 worlds, and you've got some images to show us. Can you tell us what's going to happen next with Pestival and the whole experience?
So this time we're creating these 6 immersive worlds that we can take on the road and tour around, because having talked to a lot of museums in the UK and abroad, they've said that what they really want to do is to be able to travel to the heart of cities with their news rather than be stuck behind the walls of a museum. And so we're facilitating them going out on the road and creating educational, environmental situation which is totally experiential. So we're doing what they can't do. And I'll show you what I mean. So this is the first world. And do you know Mr. Ben?
Yes, of course.
Okay,
Yeah.
That's a generational thing. He gets to go to different worlds by putting on a hat and then dressing up. So this is a way you can experience the world that insects come from, or worlds that we're connected to through insects. So the Amazons, the lungs of the planet, obviously pollinated by insects. Insects are doing their job yet again, underappreciated. And this is a VR experience. So you get to shrink to bug size and see the world, especially the Amazon, through bugs' eyes. So plants will turn infrared and start flirting with you. And you'll see the canopy from below, and you'll start to reconnect with your insect self before you go into the next world.
Sounds very Honey, I Shrunk the Kids, right?
There's an element of that there, because I think entertainment is a great vehicle for education. And it doesn't mean you have to dumb down, it means you have to try harder.
Sure. That's world 1.
I'm not showing all the worlds, I'm showing some of them.
Great, that's cool. What's going on? This is a cathedral, right?
So, yes. So this is a Pollination Palace, very Las Vegas. But actually, this is a MRI scan of inside a South Australian beehive, circular. And it's kind of like the cathedral to the Lafayette Palace, but actually it's glass. And if you look really closely, you can see the pupa and the varroa mites in the glass ceiling. And then we have a honey chandelier, and this is landing pads for bees and places where you can go and pupate and be with the bees, and it smells of wax and honey. So it's a place where you can reconnect with nature, and you're inside, I can't say the name yet, will be revealed in January, but you're inside an amazing park, and then we transport these experiences to the park. So yes, you get to go to the Amazon jungle, you get to go inside a beehive, you get to go to a crime scene.
Right,
obviously
this is CSI,
not committing the crime.
Right. What are insects going to teach us about solving crimes?
So forensic entomology has been around for time immemorial. So insects have always helped solve crime. And if you look at the first crime back in China, I think it was I think it was 713 BC, like ridiculously early. And they lined up 4 suspects in a field, all with their shovels, and they had to figure out who done it in terms of committing the murder. And they figured out it was the guy on the far right because he had flies swarming around his spade, which meant they smelt the blood, because they're always first at the crime scene. So in terms of studying the pupation of maggots, you can understand the time of death and where they died, and quite often what they've digested. So for example, if someone is taking a lot of drugs or drinking too much, then the pupation of the maggot will be deformed. So it have a very large head because it's supped on booze or drugs, and a very deformed sinewy tail. So you can tell a lot from the time of death by what the maggot has eaten on the decaying tissue of the cadaver.
From eating humans to decaying tissue, you're putting me off my dinner, I have to say here, Bridget.
Well, maybe you need to start rethinking about what you eat. But this is an against the clock timed experience where you have to figure out who done it by understanding the pupation period of the maggot before the clock time runs out.
Okay, great.
And this is the final one I'll show you.
Sure.
There are 2 others, but this is so because we're working with Sonia Klaus, who's Ridley Scott's set designer, who did Prometheus and X-Men. We are going to have the set of Prometheus at the festival, and we're really promoting women in research and science in this lab. So it's about science and insects in the lab. So obviously without the fruit fly, we wouldn't have discovered the genome, but also research that we're doing studying insects. I know that there's new nanomedicine that is looking at how to study swarm intelligence to deliver medicines in a better way. So they've been researching if you've got a cancer tumour, usually you have to take medicine that is toxic and poisons your entire system. But these new nanomedicines, they'll scout out like a lead bee in a swarm, and they'll find the tumour, and then the other parts of the medicine will come down and just attack that tumour rather than the entire system.
And this is literally being used today?
Yeah, it's being studied at the moment. They've done trials already, yeah.
Wonderful. Right, this is the last of the new worlds you wish to show us. And we promised the viewers we would bring in Professor Julian Vincent, who's been waiting very patiently online. Thank you so much for that, Julian. Are you there, Julian? Can you hear us okay?
Yep, still around.
Wonderful, thank you so much. So, Julian, I gave in the intro that you've written something like 300 papers, articles, books, looking at biomimicry and what we can learn really from the living world. And I probably undersold you with that little introduction.
But, come on.
But I understand you have done a lot of work with engineers, helping them to learn how we can apply what we know from living species into practical solutions. Could you outline one or two solutions you've helped engineers come up with?
Well, it's not just engineers, it's designers. And I mean, most people think of engineers as metal bashers of one sort or another, and there's a far greater range of things that they do. And I suppose an engineer is trying to make a system or a mechanism which has got useful but also predictable behavior. One of the nicest ones, which is still in development, is being done by a guy called Ferdinando Rodriguez in Baina in Imperial College, and he's basing his ideas on the way in which a wood wasp drills into wood. The wood wasp wants to lay its eggs in the wood, and so it needs to be able to make a hole which sort of moves around a bit because it's looking for the larva of another insect in which its eggs are going to grow. So what we end up with then is a way of having a tube which can be navigated through some medium or other, and which can then curl around, but doesn't really require very much pressure to push it in. Actually, it pulls itself in. That's what we discovered. And so we got to that sort of stage with it. And I gave a talk at Imperial College, actually, in London a few years ago, and talked about this wasp and what fun it was. And I thought it could make a very interesting endoscope, you know, something which the medic will push into your body, and it's got a camera on the end of it. And so the medic can then have a close look at what's going on inside you. So Ferdi got very excited about this. His father is a neurosurgeon in Italy, and Ferdi is very interested in this sort of stuff, and of course has sort of got the culture as well. So we had about 3 or 4 chats in the pub, I suppose, over a period of about 4 or 5 weeks, and then Ferdi managed to get a little bit of money together and started off a beginning of a project, and bit by bit he's developed now using bits of plastic which look a bit like the plastic that you have on the top of a Ziploc plastic bag. That's part of the mechanism. A system which can work its way through actually very, very dilute gelatin, which is about the same sort of consistency as a bit of brain, but go around corners. Now, when you compare that with the sort of endoscope which the brain surgeons use at the moment, which is something like several millimeters in diameter, but worse than that, it's actually stiff, and so you push it in, so it's displacing brain cells and heaven knows what, but it's very, very quickly going to come across a rather important bit of brain. You don't want to push it through that. Whereas the system that Ferdi's developing now, with quite a few £1 million grant money, because it's obviously going to be very important and successful, actually will go all the way around some of these rather important bits of brain, come out the other side and be able to go right into the middle of your head. So that's one really rather nice, successful bit of engineering. It's very much on the not quite nanoscale, but very much on the micro scale, and seems to work very well indeed.
I mean, that sounds like a really fascinating and obviously exceptionally useful way we can learn from living things. And we've had a question that's come in from folks online, and please do keep those questions coming in. Rachel has asked me, how does the engineering and design world react to the idea that we should learn from living things? I'm sure you've been working with engineers and designers for a very long time, and some probably think
there's a huge political problem there. I don't mean sort of party political, I mean in terms of what's seen to be useful. One of the big problems we have at the moment is that there's an awful lot of lovely little stories in nature. I've just told you one of them, but an engineer requires a far firmer background in theory and needs to have very, very reliable mechanisms. Now, obviously, natural mechanisms are probably a lot more reliable than ours, because the insects, the bees and the wasps and the flies have been around a lot longer than we have. So they're obviously doing some very reliable things, but they're doing them in a very different way. Although we can find out some little tricks and teases, what we really need to be able to do is to work out a proper system where we can present to the engineers answers of the way that biology does things, but in a language which engineers understand. I mean, it's useless for a biologist to go up to an engineer and say, hey, you ought to be playing around with these soggy, bendy things, and they're going to produce a wonderful mechanism for you, which you'll then be able to save the world with. I mean, the engineer won't believe you. He'll say, no, actually, I need to work with some sort of a plastic whose properties I know very well, some sort of a metal or some hinges or something like that, again, whose properties I know very well, so that I can produce something which is reliable. And so we're stuck somewhat at the moment at this sort of bridge between the two areas of science. And there's some people who are, some engineers I know who are utterly fascinated by all this. Say they can make a copy of an eye of an insect, which can look in all sorts of directions at once. And they're making quite a lot of use of these things, but they're only tiny, tiny little bits of the natural world. So one of the things I'm trying to do is to systematize this in some way, so that we can actually present engineers then with a system that they can ask engineering questions, and the answer comes out of a biological mechanism, but again, couched in terms that the engineer can understand and do something with. It's not an easy thing to do, but I'm sure that that's the only way we can do it. We have to work out a way in which engineers, who many of them are really fascinated by biology, but they don't know how to cope with it. We've got to help them to cope with the complexity, I think.
Super, thanks, Julian. I want to move on to the work that you're doing with Bridget and bring it all back together now as we move into the last few minutes of this event. And I understand you're helping build an insect universe in London. Could you start us off by telling us a little bit about that, Julian, and what your particular role is there?
An insect universe?
Wow. Well, Bridget tells me you're going to do it.
I'm afraid I wasn't at the last group meeting. I had other things to do. I was over in Syracuse in the USA, actually, talking to some of the people who did the original work on the termites that Bridget was talking about. And so we're developing some of those ideas now. About the only thing I've been able to contribute so far is the concept of having bits of plastic embossed with some of the wonderful colors that butterflies and beetles have. But I'm sure Bridget's going to pose all sorts of other interesting and knotty questions at a later stage. I mean, that's what I enjoy so much, taking an idea from insects and then making them available to other people who want to see some of the fascination in them.
It's your opportunity then, Bridget, to make your pitch to Julian.
No, I think that I brought Julian back into the group because Arup are creating these 6 immersive worlds with us, so they're our main partner. And then Michael Paulin, who is a diff favourite, is the architect involved, and Julian Vincent quite often comes hand in hand with Michael Paulin and vice versa.
We're such good friends.
Yes, and work very well together and argue very nicely together. Yep. But there was 2 things that had come out of the group when you were last there, and we're very much looking forward to you coming to the next workshop, which were, they're not insects, they are arachnids, but they're welcome, about the joints of spiders, and also, yes, this material that is iridescent but also waterproof that we're looking to explore. But the spider's knees was a nice comment that you made.
I'd forgotten about that, yes.
Right, guys, we are running very low on time, and I have got a great question that's come in from a Joe online. Joe says, Pestival seems to unite the arts and sciences beautifully, so that it's sincere and accessible. Why is that important, and what advice would you give to other artists, scientists trying to do this in a meaningful way?
Bridget, gonna lead?
Okay. Well, Julian can answer why I managed to embroil him in everything I do, and he seems to be a willing participant. I think if the great thing about the natural world, and obviously insects are my thing, is that it has great stories. And if you're a storyteller, great stories bring all these different disciplines together. And I think it's going back to not separating art and science, because real science and real maths is an art and real art is a science. So not separating them, but seeing them as all these different disciplines coming together to create something very meaningful. And that's why Pestival works, because it's bringing everyone together and saying, let's do the best thing possible on behalf of the insects to reconnect us with the natural world.
Yeah, I go along with that actually. I got interested in insects when I was 6 years old, and I mean, if you get interested in something at that age, you've lost it. You'll do it for your life. But I was fascinated by the way that they move. Obviously by the colours, later on by the natural history, but the way you can see everything. I mean, they wear their skeletons on the outside and probably their hearts as well. And they move like little machines. It's wonderful. I have a Morgan three-wheeler as well, which is a bit like that in that the engine is hung on the outside and you can see all the bits moving. And it's so fascinating to be able to see the functions as they happen.
Can I just say, talking of vehicles, if you look at tanks, exoskeletons, if you look at planes and different war vehicles especially, a lot of them are learnt from the natural world, whether we like it or not. They've even got the right names, the mosquito, the de Havilland moth, you know. That you start realising that they're all connected and they're actually, probably without realising it, we've learnt more from the natural world
Sorry,
than
the
we
lights
give
are
it.
going out. That's better.
It's an omen. We've learnt more from the natural world without realising it. And I think maybe it's an awareness that we're just starting to be aware that we've learnt from them. And now it's an awakening that we can learn more because we're receptive to it.
Wonderful. And I'm afraid we are running out, or we have run out of time. So I have to say to both of you, Julian Vincent, thank you so much for joining us in this session. I believe you're in Copenhagen or thereabouts tonight, Julian. So we appreciate you taking the time out to join us. And obviously, Bridget, for joining us here in the studio. It's been wonderful to hear from both of you about this wonderful event, Pestival, which is coming back. When is it coming back? We never said that.
May 2018. It's a long build time.
Okay, somewhere at an undisclosed location in May 2018, Pestival is back.
The best location in London.
Excellent. Right. Okay. Wonderful. So I didn't quite get around to all of the questions the online audience had. I really apologise for that. But thank you so much for sending those questions in. The Diff shuts down for the weekend in terms of live shows, but it stays alive on the website. Everything that has passed so far on the Diff is available to watch on Catch Up. So go to thinkdiff.co and browse through the hundreds of sessions that we've already broadcast as part of the Disruptive Innovation Festival. We heard today that insects have great stories to tell, and we heard about Pestival and the way in which they tell those great stories. There are many more great stories at thinkdiff.co, so go tune in there and have a great weekend. Thanks very much, and goodbye from me.